2025. At exactly 7, Flamingo missiles launched from Ukraine's Odessa coast are rapidly advancing toward their targets in Crimea. These bulky missiles plunged toward the heart of Russian defenses. It was as if they were waiting to be hit by S-400s. 3 Flamingo missiles were easy targets, but they had been fired directly during daylight hours. At that, Russian generals were planning a new attack via Crimea and had interpreted Ukraine's preparations as defensive. Ukraine was actually counting on this. The moment of attack is actually the weakest moment and creates gaps in defense. 3 Flamingo missiles, each weighing 7 tons, with a range of 3,000 kilometers and capable of carrying a 1,150-kilogram warhead, were transported to the launch site. Flamingo missiles were in plain sight for the first time for a rational attack, as these missiles protecting Crimea's airspace were actively on duty. Therefore, Kiev took all the risks, because today, a small variable would be added to the picture. A millisecond delay in tracking and an incorrect priority list. Generals thought this was just a defensive anomaly. The Ukrainian plan was waiting for precisely this moment. First, a silent curtain would fall, then a fat shadow would glide low. Preparing these missiles for launch was a lengthy process. In addition to the missiles, the UJ-26 long-range kamikaze drones were another key component of the attack. At the start of the operation, around 7 a.m., there was a flurry of activity at the Russian Secret Service building in Armyansk. Russian commanders and intelligence officers were involved in planning drone attacks on southern Ukrainian towns. Additionally, helicopter apron traffic was about to open on the Simferopol axis. The Russian patrol plan along the Sevastopol coastal security line was locked in for the morning shift. The Russian army was likely preparing for a mass, simultaneous attack via Crimea. However, a few minutes later, an inconsistency would be seen in the regional air picture of the Crimean Peninsula. First small, then rapidly growing. UJ-26 drones and 3 Flamingo missiles. This attack combo would shock Russian intelligence officers and elements of Russia's Black Sea Fleet. In the first stage, the drones were sent towards Crimean airspace. The UJ-26 drones were expected to reach Crimea in approximately 45 to 50 minutes of flight time. About half an hour after these drones were sent, 3 Flamingo missiles were fired. The time for these missiles to reach their target was calculated to be approximately 15 minutes. In other words, both the drones and the missiles would create tension in Crimean airspace at the same time, and the targets would be hit by these elements simultaneously. As the drones began to approach Crimea, 3 Flamingo missiles were fired at 5-second intervals. Each missile switched to a terrain-following profile parallel to the coastline at low altitude. The flight altimeter, inertial navigation, and GNSS were tripled for redundancy. In the event of GNSS loss, the radar altimeter and digital terrain reference were prioritized. The missile speeds remained low per hour, below the radar horizon, without being detected. The 1,150-kilogram warhead exceeds the threshold for structural collapse or functional paralysis in a single strike, producing a combination of destruction in underground spaces with a bunker-busting delayed fuse. This scale corresponds to more than twice the explosive mass of a Tomahawk. Therefore, when these missiles hit Russian military bases, only explosion and destruction could occur. Furthermore, the Flamingo, manufactured with a fiberglass composite body, was designed to withstand Russian electronic warfare systems. In this mission, the targets were close range, but the variety of approach vectors. The initial impact in the attack operation came from drones. Low-profile kamikaze UAVs entered at low altitude from the northwest and northeast of Crimea. Each UJ-26 drone carried a high-explosive payload in the 25 to 30-kilogram class. Due to their composite body and small radar cross-section, 1 or 2 cells per scan on fixed antennas, providing point-of-impact geometry to the power distribution cabinet, waveguide, and field fiber centers with optical infrared sensor pairing. The drone speeds 180 kilometers per hour, with flight control via GNSS plus INS and backup optical reference. Range parameter was maintained between 200 and 400 kilometers depending on the target, which was sufficient navigation even when exposed to electronic jamming. Blinding strikes add delay to the signal processing chain, reducing the lead time window to seconds. This meant Russian air defenses had very little time to intercept without error. However, Ukrainian drones were rapidly approaching targets to completely eliminate this intercept window. The first blinding strike hit the power distribution cabinet of the 96L6AP detection radar. The explosion did not knock out the antenna, but it increased the delay threshold within the power supply and signal processing chain. Line present, no identity, effect on the screen, and extended the operator's recognition classification cycle. A few minutes later, the waveguide M1 coastal surveillance unit broke. The antenna continued to rotate, but the signal-carrying vessel was severed. In a densely layered network such as Crimea, 100% blackout is not practical. The real value is to impose a few minutes of delay on the reaction chain. The Pantsir/Tor batteries in the lower layer reacted reflex. 2 kamikazes were shot down. However, the other 4 reached their target cabins, and this scattered attack created an intermediate situation that appeared to be working in the radar communication network, but did not produce any meaningful traces. The 25 to 30 kilogram HE payload targeted the main power supply elements rather than knocking down the antenna. Now it was time for 2 Flamingo missiles to target the Russian FSB building in Armyansk and for 1 Flamingo to level Sevastopol. There was another major risk for Ukraine was GNSS jamming. Therefore, the Flamingo route was backed up with GNSS-INS altimeter digital terrain reference. Flamingo 1's target was the command and communications room inside the border security and intelligence base. The warhead was a delayed fuse penetrator HE composition. This setting produces an explosion inside the volume after passing through the outer shell. Distribution, network backbone, rack systems, cable trays, infrastructure hubs. Flamingo 1 entered the target coordinates. Altitude was 20 and 25 meters. The strike finally occurred. The outer concrete shell of the FSB building remained standing. With a half-second delay, the internal explosion severed the energy backbone. The terminals in the command room lit up, but the network was silent. Field radio bridges went down. The operational meaning was clear. There is light, but no data. For the defender, this is even riskier blackout, because the decision-maker wastes time with the wrong screen. While this crisis environment continued in the same complex, the header was again delayed. The goal was to create a loss of function that would extend the repair cycle from days to weeks. A brief GNSS interference was observed 15 kilometers from the terminal. The missile remained autonomous, with altimeter INS and digital terrain reference. When the signal returned, the error bucket was reset. Meanwhile, the defense launched another interception via Pantsir. Due to low altitude and city reflections, no solution could be found for a frontal intercept. Although the base appeared to be administratively intact after all these Flamingo missile attacks, its command control function was completely lost. The Ukrainian side then moved on to the next phase of Flamingo 3 entered the final stretch towards Sevastopol. The target was a small pier where patrol boats were moored. The 2 strike points selected were the fuel supply manifold and the small command cabin at the pier. So why were these 2 points targeted? Because if these lines are severed, even a solid pier block becomes inoperable. Boats cannot dock, the fuel cycle is interrupted, and diver and barrier operations are delayed. F-class patrol boat suffered heavy damage after losing its mooring connection. The damaged vessel was identified as an A8 Kivas, or A25 PS hovercraft, designed to carry 8 or 25 armed soldiers or Marines. For the others, the connection and fuel cycle were interrupted, the quay surface had collapsed, and the fuel line was severed. Defensive fire continued, but there were no missiles left to fire. The window of opportunity for attack closed. Because the reaction was delayed, none of the countermeasures provided any significant damage reduction. Russia suffered the shock of Flamingo missiles and kamikaze drones in Crimea. On the contrary, they had the potential to shoot down all cruise missiles simultaneously. However, Ukrainian sources reported that none of the missiles were shot down. The situation that facilitated the operation was low altitude. That is, we are talking about 20 to 30 meters high. The radar horizon is a fixed area. A low-flying target can only be seen by a fixed antenna when the target radar line of sight is converted due to ground curvature. The radar sees it, the target is almost overhead. If front intersection cannot be calculated in this window, the back chase particle-headed interception scenario is used. The particle-headed reflections also cause false tracks. The result is that the lock is broken and interception is missed. This does not mean that the S-400 is weak. The combination of geometry plus timing renders this Russian air defense system ineffective in a short window. But this mission was a difficult threshold. As mentioned, it would be a mistake to underestimate the S-400. Success depended on producing a delay of a few tens of seconds and turning the low-altitude geometry to the attacker's advantage. Flamingos kept deep bunker targets at the single-shot threshold with their fat warheads. UJ-26 operators did not miss the millisecond window. Kamikaze UAVs produced dilution rather than total blackout here. Blinding was kept at the threshold, and the missiles affected 3 targets in the same minute with time-on-target discipline. This created a load distribution that prevented the defense from focusing on a single target. The difficulties on the ground and the margin for error
probability of the attack succeeding was actually much higher than the probability of failure.
Shot down. One wave was delayed, and the 96 UAVs were shot down. 6 AP showed instant recovery. The Tor battery fired 2 interceptors at Flamingo 1. If the lock-on scan had gained continuity, a real risk could have arisen in the forward intersection window. GNSS jamming could have caused the strike to miss the target by tens of meters if there was no altimeter digital terrain reference at the terminal. This would have meant an explosion outside the target. None of these were left. The route and terminal were backed up. The target set was distributed according to the 2 critical points rule instead of a single large piece. Ultimately, no chain of errors occurred, and all 3 Flamingo missiles found their targets. The final damage effect assessment after the operation was quite critical. The FSB border base has no command control function. The power distribution backbone is severed, and the field communications cabin is burned. This means that even if the base's administrative building remains standing, the Sevastopol pierhead has collapsed. The fuel line has been severed. At least one patrol boat is out of service, and the refueling cycle for the others has been interrupted. The fact that 3 Flamingos produced results on this scale for the first time showed that even a layered shield, when combined with the warhead mass and low-altitude profile, can be forced to produce gaps measured in minutes. What follows depends on reorganizing the sensor nodes with redundant power signal fiber plans and deploying the gaps left by this morning's 3 strikes will continue to be felt on the calendar. Thank you for watching.
August 12th, 2025. A Russian convoy carrying about 50 tons of ammunition moved into a refueling stop. But only minutes later, 2 first-person view suicide drones surged forward nearly 125 miles per hour, like deadly arrows piercing straight toward the trucks. 2 strikes in less than 5 minutes, and the entire stockpile erupted. The blast could be seen from more than 12 miles away. This was not just a raid. This was the moment the rear lines turned into the front line. At 10 a.m., August 12th, 2025. From a makeshift launch site near Svatov, on the outskirts of Starobilsk in Luhansk, 2 first-person view tactical UAV regiment entered their final checks before a strategic strike. 15 minutes earlier, a modified DJI Mavic 3 had been launched. It acted as the scout, capturing infrared images, transmitting real-time data to the command post, and guiding the 2 attack drones toward their targets. The target, 5 Russian Ural trucks loaded with ammunition, moving toward the improvised relay hub, Idar-17, on the north bank of the Idar River. Their mission was to deliver over 50 tons of artillery shells and rockets, enough to increase Russian fire density to levels that could threaten Ukraine's supply staging areas, river crossings, and forward medical stations. Not allow that to happen. For days, the 14th Regiment, working with intelligence networks, had tracked the convoy, marking refueling times, crew habits, and combining UAV imagery with electronic reconnaissance to pinpoint the moment the trucks would have to halt for inspection and refueling near Starobilsk. The location lay outside the umbrella of fixed air defenses. No radar, no missiles, no electronic warfare teams. At 10:02 a.m., from 9 miles out, the Mavic 3 streamed encrypted real-time video back to the field command post. On screen, the 5 engines glowed as distinct heat signatures. To Ukrainian eyes, it was a perfect cluster target. A single precise strike could set off a chain reaction, wiping out the entire convoy in under a minute. No further confirmation was needed. Signal encrypted. Coordinates locked. Immediately, the 2 FPV drones launched. In the initial phase, they used GPS combined with inertial navigation, flying low at an average 35 to 50 feet to evade ground radar or low-frequency surveillance. Cruise speed was held steady at 80 miles per hour, fast enough to shorten the flight time, yet slow enough for the operator to maintain pinpoint control. At 2 miles out, The drone's optical cameras, 5 military trucks parked with 20 to 25-foot spacing, all facing south. The cameras acquired the target. Several soldiers walked nearby, but there was no sign of guard posts or improvised defenses. Just as intelligence suggested, this was treated as a short, safe stop. Drone carried a PG-7VL-shaped charge warhead, weighing 5.5 to 6.5 pounds, fitted with an 85mm copper liner. Inside was 1.5 to 2 pounds of OK-Fall explosive, equivalent in power to high-grade TNT. On detonation, it produced a focused jet exceeding 32,000, enough to pierce 0.6 inches of truck steel plating and ignite the ammunition within. Trait 20 inches of tank armor against lightly armored transports. Its effect was overkill, like smashing an eggshell with a sledgehammer, not only piercing but triggering uncontrollable secondary explosions. Aim was not to destroy trucks individually, but to hit the formation's vital points. Truck number 3 at the center to start the chain reaction, and truck number 5 at the rear to lock the convoy in place. With these positions struck, the heat and shrapnel from the initial blasts would cascade through the rest. At 10:03 a.m., at only 1,970 feet away, both drones entered their final approach. Navigation switched fully to optical recognition, altitude dropping from 33 feet. The approach to steady for the first 5 seconds, then UAV-1 locked onto truck number 3, the perfect central kill point to ignite a spark explosion and spread heat into adjacent vehicles. The FPV crew commander kept the approach ramped up to linear acceleration. At just 98 feet out, UAV-1 surged to 87 miles per hour, a steel arrow carrying compressed explosive mass, tearing through the air, slamming into the structural weak point, and locking the entire convoy into chain reaction detonation. On impact, the shaped charge ignited. A jet of hyperheated plasma burst through, shredding the truck's steel like foil. The penetrator's force focused on a spot just a few centimeters wide, but the contact temperature instantly spiked to 5,100 to 5,400 degrees Fahrenheit. Propellant charges, fuses, and packaging inside the truck ignited almost immediately, generating intense heat through a chain reaction. Within 5 seconds, the entire cargo bay had become a burning time bomb from within, spread directly to the 2 adjacent trucks, vehicle number 2 in front and vehicle number 4 behind, forcing the entire formation into thermal overload. This was the moment the battlefield shifted into full chain detonation mode. The sound of the first blast and a towering column of fire sent the escort troops. Some soldiers fired wildly with AK rifles, aiming at the silhouette of the remaining drone as it flashed past. But at that distance, with the drone's closing speed, small arms fire was meaningless. Scrambled to maneuver the convoy out of danger, but the spacing was too tight, and the fireball erupting from truck number 3 created a wall of flame that sealed off any escape. In under a minute, the convoy was trapped in place. Almost simultaneously, UAV-2, the second strike drone, executed its programmed flanking run, looping behind to approach from the opposite direction. The target, truck number 5, the rearmost vehicle. This was the critical tactical move. Strike the tail, lock both ends, and trap the entire formation inside a kill zone. The UAV commander adjusted UAV-2's speed to 75 miles per hour, just enough to maintain an optimal angle of attack without overshooting the target while keeping the optical lock steady. Veered diagonally from the rear right, slamming into the cargo bay of truck number 5, the shaped charge punched through the shell, detonating in a second fireball. Flames erupted, merging with the blaze of truck number 3, creating twin pillars of fire engulfing the formation. Truck number 3 detonated completely, unleashing a shockwave across the entire convoy. The blast ripped apart truck number 2's steel shell, hurling shrapnel into truck number 1 at the front. The chain reaction had begun. Moments after truck number 3's total detonation, local temperatures surged past 6,332 to 7,232 degrees Fahrenheit. Fire columns and shock waves hammered into the neighboring trucks. Truck number 2 erupted violently. Paint, plastics, and external coverings ignited in under 10 seconds. successive blasts. The rising pressure blew open the cargo bay, venting fire straight upward into a massive thermal column, a textbook case of detonation cook-off, where propellant self-detonates after surpassing safe thermal thresholds. Truck number 4 suffered a dual strike, residual flames from truck number 3 in front and the inferno from truck number 5 behind. The compounded heat triggered a full detonation of its load. This was the third major blast in under 2 minutes. Steel fragments and artillery shells were hurled more than 495 feet, damaging nearby infrastructure. These successive explosions, Starobilsk was transformed into an uncontrollable firestorm. Fire pillars shot tens of meters into the air, with black smoke visible from over 12 miles away. Each blast scattered new fragments, endangering every Russian soldier nearby. Secondary detonations continued as shells and rockets in the cargo bays ignited at random. Truck number 1, initially intact, was torn apart by shockwaves from truck number 2's explosion. Shrapnel punctured the cabin and cargo bay, spreading fire. Within seconds, truck number 1 was fully ablaze. At this point, all 5 trucks were destroyed. At least 4 completely detonated to twisted wreckage. Moments later, blue flames jet skyward as transformer oil burns fiercely, merging with the dense black fuel depot strike. Flame and smoke fuse into a towering wall that blankets the entire industrial. Black smoke already billowing from the earlier. The operational result was indisputable. With just 2 drones and 2 precise strikes, the entire convoy of 5 ammunition trucks was annihilated. 40 to 50 tons of artillery shells and rockets were destroyed in under 3 minutes, the dual fire centers locking the formation and driving the chain reaction until every magazine was consumed. Exact figures remain unknown, but with an average crew of 3 to 4 soldiers per truck, drivers, escorts, technicians, plus guards, casualties are estimated at 20 to 25 personnel. Blast deformed the concrete roadway and heavily damaged surrounding infrastructure. Russia was forced to cordon off the area due to large amounts of unexploded ordnance. After, the Russian Emergency Situations Ministry, along with EOD teams, firefighters, and medics, moved into the hot zone. Route P66 was sealed, and ambulances stood by along the safety perimeter. This strike did not merely destroy a convoy. It sent shockwaves through Russia's entire logistics system in Luhansk, because it severed the Starobilsk-Svatove-Kupiansk supply route, the key artery feeding ammunition to Russian artillery groups in northern Luhansk. Post-blast clearance and demining would stall transport for at least 5 to 7 days. Eliminated an ammunition stockpile equivalent to half a month of fire support for a Russian artillery regiment in a single night. Forced Russia to change its transport model, from concentrated convoys to dispersed smaller units with tighter escort. This cut efficiency, raised costs, and slowed resupply. There is no such thing as an absolute safe zone. Even Starobilsk, long regarded as an untouchable logistics hub, was penetrated and struck with precision by Ukrainian drones. It also increased pressure on